What's going on, everyone, and welcome back. Today we are going to be working on like image culling or slicing, or however you want to specify what the name of that would be. So basically what it is we have a drawing area and we do not want any textures or whatever we're drawing to be outside of it. So how we're going to do it is we have a drawing area just like this. And then we have, let's say we have a texture being drawn right here. We only want this right here to be drawn. We don't want all this to be drawn. So we're going to be doing some magic, I guess, some mathematics to get this rectangle instead of this whole rectangle. So it's pretty easy. All we're going to do is we're going to get the max float value on x, the x position of each rectangle. So max would be this, and same thing with the y. And then we want to get the minimum of the right side, which would be x plus width. So we would get the minimum of that, which would be right here. Same thing with height. I mean, it's very simple. So once we have the positions of the vertices, which would be here, 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 and here, we know how to get the UV coordinates. So if this is 1 and this is 1, then we know that, or it would be, what, 0.25 or whatever this way, 1 this way. We can check the overlap of, for instance, x would be, what, close to, let's just say that this is half. So it'd be half of what the original UV is. So it's very simple. But first, at the end of the last video, I know we added a cleanup method and we never actually implemented it. And I believe it was it mesh that we added, or was it textures? No, texture.cleanup. Mesh.cleanAllMesh. So we'll just put that in there. Mesh.cleanAllMesh. There. Oh, that was painless. Okay. So the first thing we need to do is we need a rectangle for the current size of the screen. We can currently get the width, we can currently get the height, but we can't get a predetermined rectangle. This will just make it easier for us when we're doing the calculations. So we can just grab that rect straight from the app. And as you can tell, I changed that from green to white. All right, so let's go into application and create I'll put it right there, whatever. I like to keep everything tidy, but private static rect r. And then when we initialize, want to initialize it to r equals new rect 0, 0 width height. So then that initializes it. And then we can use the set function since it's already created. And go right here. Say, or right here. So on window resized. Then we're going to say r dot set and say ww 0, 0. So then that sets that. And then we need a getter. So public static rect get rect. And return R. So that's just going to get the current rectangle of the screen. And I believe that's all we need in application. Alright, so the next thing we need to do is we need to prepare the GUI, do some of the stuff that we need for the GUI, which actually before that in the last episode I said that we were going to only use one drawing area at a time. So we can begin an area, end an area, begin an area, end an area, so on. We couldn't put areas inside of areas. Well, I decided against that. Against just doing one area at a time. Because I figured, you know, it might be a little bit easier coding wise and grabbing the size of the rectangle for the scroll view later on down the road. I normally just use one area, but for the sake of the tutorial, I don't want to not add it, you know, just out of spite. So I'm going to go ahead and add this just so that it's easier tutorial wise, and in case anybody wants to use it in game, which I don't really see why, but you know, there could be reasons why. So whenever we draw an area, let's say this is a window, and then this is a window, and then we just draw an element inside of here. So then, since this is the parent rectangle or parent window, we would only want to render this rectangle, you know, and leave all this stuff out, but still have it parented to this window. So to do that, we need, and I don't normally add this like I said, so I'm just going to kind of wing it from here, because I just decided this like what, a couple minutes before I started this video, so we'll wing it and see what we come up with. So we need a private static list. Yeah. We'll say areas equals need a list of rectangles. Areas equals new array list of rectangles. I guess we haven't added those yet. So let's do that. All right. So we need to set that information. So I know I'm saying so a lot, but whatever. I think inside of the prepare method, because that would be every time right before everything is drawn, I need to clear the areas. Disable, yeah. So right here, say areas.clear, and that will clear the areas that we have in there. As long as you're ending your areas, then there shouldn't be anything in there besides our regular application size, because we're going to put that as number 1. So we'll clear the area right before, say areas dot add we did add that application.getRect, so that will get our rectangle, so that makes it a lot easier. So we'll add that, and then we'll say area equals areas dot size, areas dot get areas dot size -1. Okay. Yeah, so I'm leaving this area up here. I could just go ahead and get rid of it, but some of our code uses it, and it may just be easier just to keep that in there. We may remove it later on down the road or something, but I don't want to mess with it right this moment. So I'll just add everything to the areas and then set the area itself. So now I need to change the area code. Yeah. Alright, so instead of this, so that begins the area. So not area equals R. I'll begin the area. And oh, I think I already have to. Yeah, because I need to get the intersecting rectangle just like how we do with culling or slicing or whatever. So we need to get that inside rectangle. So let's go ahead and add that, and we'll go ahead and add some of the other functions too to the rectangle. Might as well get it out of the way since we're already in here. So I've got the contains method. I need the intersection and to check if there's any intersections. So we'll make a Boolean to see if it intersects at all. And if it doesn't intersect, then we can just return out of it. So that way the code is never ran if it's not intersecting at all. So we'll do public Boolean intersects, and then rectangle R. So that way we can just, instead of making a static function and passing in two rectangles, we'll just use a pre-existing rectangle and just run it against another rect. So we will do if x is greater than r dot x plus r dot width. And then we need not an and. I'm pretty sure it's an R. Why is that not? Oh, because I have an or symbol. Or x plus width is lower than r dot x. Or y is greater than r dot y plus r dot height. Or y plus height is lower than r dot y. I think I've got that typed up correctly. We'll see. And if it is, then return false, else return true. And this will determine whether or not two rectangles are intersecting. And this right here is your first big collision detection function as well. So it will determine if two rectangles are intersecting, which is the same as checking if two sprites are colliding. So we'll be using this function a lot in the future as well. So, just so you know. Alright, now to the get intersection function so that we can get the intersection between. So we'll do public, we'll return rectangle, get intersection rect R. Alright, so with get intersection, there's several different methods you can do to get an intersection. But my way in particular is on the canvas that whatever you're rendering it on, or the drawing area that you're rendering on, that rectangle is what you would call it on, and then you would pass in the rectangle of the element that's going to be drawn onto it. So if you have a current area and you're wanting to do another area over here, then you would call it on the first rectangle and pass in the second rectangle. So how this works is we need to first check if the two rectangles intersect. So if not intersects R, then we need to return null, because there is no intersection, so there is no rectangle to return. So we're just going to return null. And then to make this a little shorter so that our return statement isn't just one huge line, I'll separate the positions from the scale. So I'll do vector2 v equals new vector2, and now what we're going to do is we're just going to do like how I told you how we find the x position, is we max out the x position, and to find the x plus width we would find the minimal value between each rectangle of the x plus width. So we need to call math.max x and then r.x. So then we're just getting the max value of the x. And then we need to get the max value of the y. That's it. That gets our positions. It's very simple. So for the return statement, we'll do return new rect. We're going to do v.x, v.y, and that separates that. And now the width and height. So we want to get the minimal value. So do math.min, do x plus width, and r? Yes, r.x plus r.width. And math.min y plus height and r.y plus r.height. And that gives us too high. Okay, so yeah, so I have to do that anyways. So it's a good thing I already cached it in a vector, because we're going to have to subtract. Yes, we're going to have to subtract the x position of the vector. So then subtract the y position of the vector. Yes. Yeah, that's correct. Okay. So then this gets our intersection. And I've got a kid running down the hallway. And I believe that's it for the rectangle class. Let's close it out. Alright, so back to here. Alright. Yes. It's, let's see here. Areas dot add. We'll just add it to the list of rectangles. So I'll go areas dot add. We already have the current area because the current area is going to be set as area. Area dot get intersection. And then we'll pass in a new rectangle. And what we're going to have to do is we're going to have to call area.x plus area, or r.x, area.y plus r.y, r.width, r.height. What in the world am I doing? It's got me all messed up. I hate it when the caret does that. Alright, that does that. So instead of setting area to R, we need to say areas dot get, then areas dot size minus 1. There. So we add the intersecting area to the areas and then set the area. Now as for the ending area, we don't want this. Don't want that. I will use a set function though. So we need to check if, did I do that? Let's see here. Area, yes. So it adds the area. So we need to check to make sure that it is not the first element in the array, because the first element in the array, what we're doing is we're passing in the size of the application, or the rectangle for the application. So we don't want to remove that if we're ending an area. So let's say we create an area and then we accidentally end an area twice. Well, then that completely gets rid of it and there's no more area. So we want to make sure that we don't accidentally do that. So if areas dot size equals 1, then we just want to return out of it. And that gets rid of that, or fixes that issue if it ever comes up. Remove. So we'll do areas dot remove areas dot size minus 1. So then that gets rid of the last area that we have started. I'll say area equals areas dot get areas dot size minus 1. So then this gets rid of the last area in the array, and then after it gets rid of it, then it sets the area to the last area in the array. And I believe that is it for the areas. Let's see if that worked. Make sure that it didn't cripple anything. Alright, so, well, that worked. Let's move this over a bit, just to make sure that the area is still working as it was before. Alright, so that grabs that. Let's do something funky here. Let's add a window inside of a window. So let's copy this. I don't want all that. Copy. Paste. Call that test 2. Let's copy this. I'll just create the exact same window inside of a window. So now you see that, change that to test 2. So now you see that we're doing a window here, and then inside of the window function, we're just creating another function inside of that window. And in that window, the second window, we're going to draw the texture. We'll keep that at 0 for now, for the second window. Let's make sure it all Yeah, there we go. So now we have a window drawing inside of a window. Oh, that's right. Yeah, the text up here, the reason why the text is all messed up is because we don't have text calling draw texture with texture coordinates. We're not having it call that function, so we need to fix that. I've said that several episodes now, and I think it's time. I think it's time we finally do that. So, yeah, so that works. Now all we have to do is do the culling around this box. But yeah, so multiple areas worked. Good. So now I don't have to. So now we can do that. If you ever want to use multiple areas, now you can. Alright, so now it's time for the fun mathematics stuff. So let's go into, oh, I'm in that function here. Draw texture with texture coordinates. So the first thing we need to do is we need to make sure that there is an area currently set. So like how I said, we set the area regardless of whether it's null or not. So if an area is outside of another area, so we have a rectangle here, we have a rectangle way over here, obviously not being drawn, or not supposed to be drawn, it's going to give us null. So whenever we're drawing, if the area is null, then we'll just skip it so it doesn't have to be drawn. So it'll completely ignore all of this code and all the calculations for it. And the same thing goes for the area for the entire application. So if it's not even being drawn in the window, it doesn't really care about culling because it's not being drawn in the window anyways. So it'll go ahead and get rid of that too. So now you have this will completely give you full culling abilities for your application in general. So I'm going to say if the area, still using area, equals null, then we're going to return. So area, how we have it set up is area is always set to the last element in the areas array. And how I said later, I may just get rid of that because in general, all we have to do is just use the last element in the array. We don't need a full-on variable for that. But we've already got some stuff using it, so I won't mess with it for now. I mean, it really doesn't matter. It's not like it's going to gain you any performance or lose you any performance. It's super minuscule, so it really doesn't matter. Later it'll matter, just not right now. So we'll do rect r like we always do. Now we need to get the intersection between where we're going to be drawing this texture and the area. So we'll do rect r equals area dot get intersection. We're going to need a new rectangle because we're going to be adding stuff to it. We're going to need the drawrect dot x plus the area dot x. Yeah, just like how we did right down here for positioning. So we'll change that in a few. And then same for y. So drawrect dot y plus area dot y. And then we're going to be using the same width as the drawrect and drawrect dot height. And you know what? Later in some other episodes, I'm going to add an add position and add scale function in the rect so that we don't have to create an entire rectangle for something so stupid, because we're just changing the position in these. So there's no point in even passing in those values, but we'll do that some other time. So that'll give us the rectangle of where the texture should be drawn, even though it's outside of the drawing rectangle, or could be inside of the drawing rectangle. And we're just going to get the intersection of that. So we're going to say if r equals null, so if it's completely outside of our area, then of course we're going to do just like we did up here and return out of it. So now we need to get our values, because now we know that it is inside of the rectangle. So whether it's small or drawing the entire thing in the rectangle, we can call this code. So like we did before, need to get the position values. So we'll do float x equals, yes, because rectangles is our rectangle position, and now we got to do the UV. So this part down here is for the UV. Do float x equals UV dot x plus, let's see here, let me add it up in my head really quick. 4. 1, 2, 3, 4. Okay, r dot x minus draw rect dot x, and off to the next. Going to, yeah, subtract area dot x, and then divide drawrect dot width, yeah, and then we're going to multiply it by UV dot width. Let me check my math real quick. Yeah. Okay. So we'll do the same thing for y. So UV dot y plus 1, 2, 3, 4 r dot y minus drawrect dot y. Quit messing with my caret. Area dot y divided by drawrect dot height and multiply it by UV dot height. And bam, that gives us our position. So now we need it all together. So we'll just call it U, make it a little easier, equals new rect x, y, r dot width divided by drawrect dot width, and yeah, multiply it by UV dot width. Okay. And then the same thing goes for the height. What am I doing? That doesn't belong there. Yeah. Yeah, so the same thing goes with the height. So r dot height divided by drawrect dot height and multiply it by UV dot height. And there we go. That gives us our UV position and scale. So now we just need to set it. So we'll do offset of, is it no, U. So we can just change this just like that. And change that to R. And change, we'll just get rid of this whole thing. Go R dot X, or wait, no. R dot, yes, that's position. R dot X and R dot Y. And I believe we got it. Let's see here. Bam, there we go. Now it is properly culling. Make sure that...
I don't know where's Mommy.
She's probably outside, buddy.
No, she's actually not.
Alright, hold on just a second. Okay, I'm back. So, right here, I've got it 200 wide. So let's draw the texture at 150. Make sure that it's properly culling, and yes, it is. So this window is culling this window, and both windows are culling this texture. Pretty awesome. Alright, so now let's... Why do I have this? Oh, yeah, because I wanted to change that texture, or change how the labels are called. So I noticed there's not many views on my videos for labels, creating, drawing font onto the screen. So if you were not using that, then just make sure you are creating a texture. So I'll add this function first, and after this function, then if you're not using my font or label stuff, then you can just call this function to create a texture. And hold on just a second. All right. So float. Did I make it a float? No, it's an integer. Do int ID, int width, int height. So we'll make a constructor that is going to take in these values. We'll say this dot ID equals ID, this dot width equals width, this dot height equals height. There. So if you've already got all your own font and label stuff going on, just make sure that you call this function to create this texture, or have your own textures or whatever if you're editing your own code for this GUI. Just make sure that you can pass this information. So this will allow us to say private texture to import texture. This way we can create a texture for the font. We're already creating, the actual texture ID, but we need to have an actual texture so that we can pass it into draw texture with texture coordinates. So there's the image size. Font ID right down here at the bottom. I'll call texture equals new texture. Pass in the font ID and the widths. So 1024 by 1024, because I have it set right up here. So it's always a set image size for the font. I may eventually increase this by 2, multiply it by 2, so it's 2048 by 2048, but if I do that, it really doesn't matter. It doesn't affect you guys at all. So there, that gives us a texture. I'll also need a get font ID, need public texture get texture, and then I'm going to return texture. Alright, so now our font creates an actual texture class instead of just the texture ID. So then right here says, where is it? No, oh, right here. So right there I bind the texture. No, I don't have to call this, because draw texture with texture coordinates is going to call that for us. I don't need to call that. And I'm not going to have to call that, but I do need to keep that in mind, what I'm calling. So I'm going to say draw texture with text chords. And I'm going to need the texture. So I'm going to say font dot get texture. Need a drawing rectangle. scale X. Why am I calling that? Oh, it's because X is the normal, it's X temp. So, font.getTexture, say new rect X temp Y R dot scale X R dot scale Y. Sorry, I got confused for a minute. I was trying to figure out my my rectangle, or my drawing rectangle. So then you UVs. So then I just pass in R. Okay, R. R is a glyph. How do I have that set up? Okay, so it's just like a rect, but different. So do another rectangle, R dot X, R dot Y, R dot W, R dot H. Right? That should be correct. That's going to call that anyways. Let's do text color. Pass in the color as well, because this function is just going to call this function. So we'll get rid of that as well. Get rid of the bound color, because I check it right there. So we can get rid of that. Scale Y, R. Alright, I believe that's all the information. Alright, so now that should work. Ta-da! There it is. So let's go into core. And right here I'll say GUI.label. Text I wanted to say is here is culling in action. And the X and Y, I'll do 150, just like how we did that. And it's 100, so I'll pass in 100, so it's the bottom of that texture. Make sure it's cold, and there it is. So now it is culling the labels. I love it when everything works out just perfect. I got some goofiness going on with the text padding or whatever, but I'll fix that later. All right, so there we go. That ends this episode. Next episode, we will work on either game objects or we'll work on either game objects or scroll bars. I don't really know for sure what I want to work on next, but it's one of the two. because our hierarchy is going to have all the game objects that are in the scene. So I'm probably going to do game object before the scroll bars just because that's the more important thing. That's what's going to be going inside of the hierarchy. And then whenever we get to the component window, it will look just like this. So it'll say what component window or whatever, and then each component will be inside of its own window, just like that. Except for I'll use a different window skin. All right, well, that's it for today, and I will see you on the next episode.